Do you want to know how to add the logic for castling to the possible moves of the king? Watch this video to find out. Hello and welcome to part 30 of the series on how to create a chess game with ReactJS. In this part we are going to work on getting the castling moves in the possible moves from the king. What is castling? Castling can occur when the king hasn't moved yet and any of his rooks haven't moved either. So say, for example, the king has not moved and his left rook hasn't moved either, then the king can castle with the left rook. However, he can only castle with the left rook if there are no pieces in between the king and the rook. So as you can see right now, there are all empty tiles. That's a requirement in order to castle. So right now we have empty spaces between the king and the rook, which is good. Another requirement is that the spaces between the king and the rook cannot be in danger. So right now all the spaces in between are safe. But what if we have the enemy horse on this location right here? That means that this tile right here on the left of the king is being attacked by the opponent's horse, and that means that we cannot rook or we cannot castle. Same goes for the right rook. The horse is also blocking the king from castling to the right side. So let's move the horse or the knight away. So in this situation, the king could castle with any of the rooks. Castling can only happen once, and once you have castled, well, you cannot castle anymore, because one of the prerequisites is that the rook that you are castling with and the king that is being castled haven't moved yet. So right now we haven't moved. We can castle with any of the rooks. If we move the left rook to the right and we move him to the left again, it's still in the same position, but the rook has moved, so we cannot castle with it anymore. Now we are only able to castle with the right rook. If we move with the king and we move him back, now we cannot castle at all anymore because the king has moved, which means that castling is no longer possible. In order for us to implement castling, we need to know if a piece has moved already. In order to do that, we're going to open up our source, models, and then our piece model. And inside of here, we are going to add a new property, which will be hasMoved, which is a boolean. And this boolean needs to have a value in the constructor, so this .hasMoved is equal to false, otherwise it will throw an error. And right now every piece that we construct will have a hasMoved property of false. However, if we clone the board, that means that we want to get the new positions of the pieces, and we also want to have the hasMoved property from the previous pieces. Right now it's always hard-coded to false. This should be a variable. So in order to make that a variable, we want to add it to the parameter in the constructor. And we're going to say hasMoved, which is a boolean. And then right here is equal to hasMoved. What we want to do as well is we want to move this hasMoved before the possible moves. The reason why we want to do that is because the possible moves are assigned a default value, which means that we don't need to necessarily pass it in. Well, if we put the hasMoved after the possible moves with the empty array, that means that we always need to define the possible moves, because we also always need to define hasMoved. Right now, the way that we write it right now means that we don't need to pass in the possible moves if we don't have them, because the hasMoved parameter is occurring before that parameter. Now that we have added this, we should get some errors. I see at the bottom right here where we clone the piece, we need to pass in a parameter, and we are going to pass in this.hasMoved like so, and then we can keep the possible moves like this. Great. So right now we should have a property on the piece which says if it has moved or not. Now we can use this property. All right. So in our referee, in our components and then the referee, we have a function which plays a move. In this function, we check if the move is valid. Right here, we prevent the inactive team from playing. And then down here, we want to play the move. So right here, we say cloneboard.playMove. And then we have some logic. Let's see. En passant move, valid move, play piece, destination. All right. So since we are not using the previous board, we can also omit it like this and then it will still work the same, but now we don't expect that as a parameter, which makes the code a little bit more clean. So first of all, we clone the board, we increment the total turns, we play the move. Inside of this function, we want to also modify the piece. So right here, we have the piece that is currently playing. And then down here, we check if it is an ampersand move. Then we, create a new array. And otherwise, we also create a new array. Otherwise, if it is neither of them, we return false. And, we will return true by default. Great. So we have two places where we create a new piece array, which is here. Let's see. Here is the first place, and then down here is the second place. And we want to update the hasMoved property in both places. So down here, we want to say if piece at same position play piece. So if our piece that we are currently looping through is the same piece as the play piece, then we want to do some things. We want to say piece.hasMoved is true. And then down here, so this is for the ampersand functionality. Now the ampersand piece will have a hasMoved of true. Then down here, we also check if piece same position play piece. We also want to say piece.hasMoved is equal to true. Now we update the hasMoved property on the pieces. Let's see if this actually works. So we're going to save up the referee as well. Scroll down here because we have an error. For the promotion pawn, we also create a new piece, and that piece has obviously also moved. So this will be true because the piece has already moved if it is on the other side of the board. All right, so up here, after we play the piece, let's see, that's down here. We want to add a console log, console.log, and then we want to log the clone board dot pieces dot filter, and then the pieces that have moved, and then the length of that. So right now in the console, we will see a log appearing, and that log will tell us how many pieces have moved. So this is equal, or this is a short version of this. So we want to check where hasMoved is equal to true, or in short, where hasMoved, which is a boolean. All right, so let's open up the console right here. And then let's refresh the page. We get some errors. I think that is in our constants right here. Yeah, because right here we are creating new pieces. And they also need to have a default value. So let's see. I also see that we don't have that for the pawn yet. So let's go to the pawn. It's right here. The pawn also needs to have a boolean for the hasMoved property. So hasMoved is a boolean. And then we also want to pass it in right here, like so. And then right here, we want to say this dot hasMoved because it comes after the ampersand. As you can see, ampersand is right here. hasMoved is right here. And we might want to make ampersand not nullable, but it's fine for now. So I just added the hasMoved boolean inside of here. And a required parameter cannot follow an optional parameter. So this is what I was talking about with the possible moves, because you can omit it. The ampersand property is a nullable, so you can also omit it. So let's not make this null, or well, let's keep this null. We are going to move this to our to-do list, and we're going to put this right here. And then we want to put the hasMoved after the team, which is correct. Team, comma, hasMoved. And then right here, team, comma, hasMoved. And then right here, where we create pawns and pieces, we want, let's see, if we open up the piece, the hasMoved comes after the team type. So everywhere where we have team type, we need to add a hasMoved. So let's press Ctrl D to select all the occurrences. And we also select the pawns, which is great. And then we press comma and then enter and then false. So by default, all the pieces will not have moved, which is true. And then right here, we want to do the same thing. I'm just pressing Ctrl D a lot of times. And then we can move our arrow key to the right, press enter. And then we say false, because they also haven't moved yet. Great. So now that we have fixed this error, we can refresh the page. It's still working as expected. Let's clear the console. And if we move this piece, we see 1. If we move this piece again, which we cannot because, well, we have turns right now. If we move this piece, we should see 2. If we move this piece again, we should see 2 still. Right? Because we only have 2 pieces that have moved. What if we move this one? We should see 3. That's correct. If we move this, it should be 4, 5. And if we do this, we should see 4 again, because there is 1 less piece on the board. Yes. And we have an undefined as well on line 93. Ctrl G is for going to a line. And then let's see, here we log the piece. Well, we can remove this console.log. And then we now know that if we play a piece and we play another piece, our total pieces that have moved are incremented, which means that it probably works. Well, I can tell you for sure it works. So we don't need this console.log anymore, and we can save this up. And what we now want to do is, now that we know if a piece has moved or not, we want to add the possible moves for the king, for castling, to the possible moves array. If we open up the bar on the left and then down to our board, here we scroll up and here we have all the move calculations. So let's see, we get all the possible moves for the pieces. And here we check if the moves are valid, and we want to remove the moves for the team that is not playing at the moment. In order for us to add the castling moves to the possible moves array, we need to do one more thing, which is, since for castling we need to have a safe passage, which means that the spaces in between the king and the rook should not be targeted by an enemy piece. We need to know what the enemy possible moves are. So I think it's best if we add the castling moves after we have calculated all the normal moves, so that we then know if the enemy can move there or not. So if we do it at the end, the enemy won't have any moves left because we removed them. So that's not what we want to do. We want to do it before that, so we still have access to the enemy moves. So for the king, we are going to create a custom method for getting the castle moves. We want to say for const king of this.pieces dot filter p dot is king. So now we only loop through all the kings. We want to say piece or king dot possible moves is equal to this dot get castling moves, and then we want to pass in our king and the piece array that we have. This will lead to a bug, because right now we are assigning the king possible moves directly to the castling moves, which means that we don't have any normal possible moves. What we want to do is we want to add the moves that we get from this function to the array that we already got from the previous function. But for now we are going to keep it like this, because then we can actually see what's happening and learn from that. So we want to create a function get castling moves. Could also directly create that function instead of creating it right here. So here we have a function get possible king moves. If I go to there, it's in the referee rules file right here. If we scroll down here, we have the bottom of the file, and what we want to do is we want to create a new export const right here. Export const get castling moves, Is that also the naming that we had right here? Get possible king moves, get castling moves, that's all right. And then we want to get the same signature right here. And then right here, I want to close it off as well. And for now, let's return an empty array. So first we are going to declare const possible moves, which is a position array. It's an empty array. And then we say return possible moves. I think that's the same as how we wrote it up here. If we go to the top of this function, we see that we have the same declaration. Great. And then I'm going to add a comment to this method, because in this method, the enemy moves have already been calculated. Great. All right. So right here, we know that the enemy moves have already been calculated. Well, let's first of all call that function right here, and then we need to import it. We could automatically import it by removing the S, typing it again, and we see where the import is from. But for those of you who want to import it manually, you can go up here in the referee.rules, import, where we have all the other imports, and we can add the get castling moves. And we could also press enter for each import, so it's a little bit more organized, but it's fine right now. And as you can see, the error is gone, and now we can add some new logic. I can also show you what's going wrong right now, because right now we are assigning the king possible moves, and we are always returning an empty array. If we refresh the page and we want to move with the king, we see that we have no moves left, because we are hard coding the possible moves of the king to an empty array. Instead of doing that, what we want to do is we want to combine it with the moves that the king already had. All right, so what we want to do right here is we want to determine if the king has already moved. If king.hasMoved, then we want to, well, what do we want to do? We want to return the possible moves, because then we cannot do anything. Okay, so here we know the king hasn't moved. Then we want to check both the left and the right rooks. So let's first of all check the left rook. And then right here, we say if board state dot pieces, board state dot filter, because we already have the piece array. And then want to have the piece that is a rook, and p dot, let's see, team type or team is equal to king.team, because we want to have the rook that is on the same team. And then we want to get the left one. So we want to have the rook that has a smaller x value than the king. However, we want to have the rook which hasn't moved only. So right here, we want to make another and p.hasMoved is false. And we can write it like this. And actually, I'm going to move this out of this if statement. And we're going to create a rooks variable, and we're going to put it right here. All right, we're going to remove this if for now. And what we do right here is we get the rooks from the king's team, which haven't moved. All right. And now that we have all the rooks that haven't moved, but they are on the king's team, we want to check, is the path between the rook and the king open? Are there no pieces in between there? And with no pieces, I mean no pieces from their own team, but also no pieces from the enemy team. Just no pieces at all. So what we want to do is we want to check every tile in between the rook and the king. One thing that I'm thinking of right now is if we recreate this very fast, we see that we already have that information. We don't need to calculate that again, because if we look at this rook, we should have 3 possible moves for the rook, which lead to the king. If we have, let's see, a move or a tile which is not possible for the rook, we know that there is a piece in between there. So we don't need to recalculate that. What we can say is, okay, we take the rook, and then we want to increment the tile until it reaches the king. So for the left rook, it's going to the right. And then for each tile that we are passing by, we want to check, is it in the rook's possible moves? Is this one in the rook's possible moves? Yes, because we see a dot. Is this one? Yes, we see a dot. Is this one? Yes, we see a dot. Is this? Oh, this is the king. All right, so we know that this rook is available for castling if there are no enemies targeting those areas. Say we move the horse back in. Let's try this again. Is this a possible move for the rook? Yes, it is. Great. Is this a possible move? Yes, it is. Great. Is this a possible move? No. Is it a king? No, it's a knight. Then we cannot castle. Only if the last space or the last tile is a king, as you can see right here, then we can castle. We are going to write this in code. Alright, so in order for us to do that, we are, first of all, I'm going to wrap this into multiple lines so it's more readable. And then what we want to do right here is we want to loop through the rooks for const rook of rooks. And then right here, we want to say, okay, what is the direction from the rook to the king? So say we have the left rook right here. If we want to move to the king, we need to go to the right. If we have the right rook, if we want to go to the king, we need to move to the left. How can we determine if we need to go to the right or to the left? Determine if we need to go to the right or the left side. Okay, say we have this rook right here on the left. We want to have a positive value because we need to move to the right. We can achieve that by taking the king's location and we want to subtract the rook's location. So if we take the x value, it's 0, 1, 2, 3, 4. We have 4 minus 0 is equal to 4, which is positive. Say we have the right rook that has x value of 0, 1, 2, 3, 4, 5, 6, 7. If we then take the king's position again as the first one, and then the rook's position, we have 4 minus 7, which results in minus 3. What we can say is, if we take the king's position and we subtract the rook's position, is it less than 0? Then we need to move to the left. Is it bigger than 0? Then we need to move to the right. We can write const direction is equal to king.position.x minus rook.position.x. And then we want to say, if this is bigger than 0, so this will be the if statement. Is it bigger than 0? Then we have 1, otherwise we have a minus 1. All right, so we have created ternary operators before. This is such a ternary operator. This is the same as an if statement. So right here we say, okay, if the king position.x minus the rook position.x is bigger than 0. So here we have 4 minus 0, which is equal to 4. Is it bigger than 0? Yes, 4 is bigger than 0. Okay, what do we want to do then? This is the if. Then we want to assign direction to 1. And then here is the else, there's the colon. If it is less than 0, then we want to assign the direction to minus 1. Now that we have the direction, what we want to do is we want to apply that direction to the location of the rook until we reach a piece. And then the piece should be the king. So if the piece, we cannot move it right now, but if the piece is another piece than the king, we know that we cannot castle. I've been thinking, and what we can also do is we could just take the last possible move. So since the rook cannot move over pieces, we only need to check the tile that is adjacent to the king, which means in this case this tile below the pawn right here. If the rook can move to there, we know that the path is cleared. Since if the horse is right here, we know that we cannot move right there. Also, if we move the enemy pawn and then we cannot still move there. And right now we can. So what we want to do is we want to say, okay, the tile that is on the left side of the king. So we want to say const destination position is equal to king.position.clone. And then we want to set the destination position.x equal to the direction or we want to add the direction to that. So let's see. And we are going to rename this to adjacent position. So what do we do right here? Here we determine the king position. So in our case, that's the king right here. Then we will add the direction that we had to that X position. So say we have the king right here and the rook on the left. Then the king is 4 and the rook is 0, which means that this will be true. Then the direction will be 1. If we then add 1 to the king position, which is 4, we will get 5, which means it goes to the right. All right, so what we want to do is instead of adding it to the king position, we want to subtract it from the king position. So right here, we want to say minus equal direction, because the direction is determined from the rook to the king, and we want to know the opposite direction. What we could also do is we could say rook.position.x minus king.position.x, and then here we can say plus is equal to direction, because then we are looking from the king's position. So let's take this example one more time. Rook.position.x, which is equal to 0, minus 4, the king position, is minus 4. Is minus 4 bigger than 0? No, minus 4 is smaller. So this will be false. Okay, since minus 4 is smaller, then we will get minus 1. If minus 4 is bigger, then we will get 1. So since minus 4 is smaller, the direction is equal to minus 1. The adjacent position plus the direction, which means minus 1, because plus minus becomes minus, will then be this position. So if we write that out, king position is equal to 4, 0. That's what we have cloned. And what we then want to do is we want to add the direction to the X position. And the direction is equal to minus 1 in our case. So we get 4 plus minus 1. And this becomes simplified, which means it will become 4 minus 1, which is equal to 3. And if we go to our board, we have 0, 1, 2, 3, which is the left side of the king. This is working for the left rook. This should also work for the right rook. If we take the right rook, which has a X position of 7, then right here we have 7 minus 4 is equal to 3. 3 is bigger than 0, which results in a 1. We still have the same king position. The direction to the X position is 1 instead of minus 1. And then we have 4 plus 1, which is equal to, and then we can remove this and this as well, which is equal to 5. We want to know the fifth X position. So that is correct, because if we look right here, 0, 1, 2, 3, 4, 5, that's this position right here. And that's the position that we need to know is 3. Great. Now we can remove this. And what we now want to do is we want to check if rook.possiblemoves.sum, and then we want to check move same position as adjacent position. So if there is a move that is the same position as here, we know that the rook can move there. Let's reverse this. If there is not a move that has the same position as that position, we want to continue. So now we know that the rook can move to the adjacent side of the king. So right here we omit all the moves or all the rooks that cannot move next to the king. So that's what the bang or the exclamation mark does right here. If we remove this, we say, okay, can the rook move to the adjacent position of the king? Then we want to continue. Well, that's not what we want. We want to say, can the rook not move to the adjacent position of the king? Then we want to continue. So right here, we know that the rook can move to the adjacent position of the king, since if it cannot, we continue, so we will never get to the bottom code. All right, so now that we know that the rook can move here, that means that the king should be able to castle. However, there is still one more thing that we need to check, And that is if any of those tiles are being targeted by enemies. Which tiles are we talking about? We are talking about the tiles between the rook and the king. How do we get those tiles? Well, we can easily get them because we can say const concerning tiles is equal to rook.possibleMoves dot filter, and then we want to filter where the move dot I or the move dot y is equal to the king dot y, king dot position dot y. So what does this mean? This means that we want to get all the moves that are on the same height as the king, which means that we only get the horizontal moves and not the vertical moves. And that should always be the moves in between the rook and the king, because the rook cannot move over the king. So now that we have our concerning tiles, we want to check if our concerning tiles are not in any of the enemy possible moves. So right here we want to check if board state dot filter. First we want to get all the opponents. We want to say p.team is not equal to king.team. So right now we get all the pieces that are of the opponent team. And then what we want to do is we want to check their moves. We're going to create a separate variable for this in order to keep it simple. We're going to say const enemy pieces is equal to this. And then if enemy pieces dot sum, so if there's any enemy where the moves, no, not the hasMoved, where the possible moves contains the concerning tiles, then we want to revert it. Then we want to say this move is illegal. So instead of doing it like this, what we could also do is say let valid is equal to true, and then right here for const enemy of enemy pieces. Here we want to check if enemy dot possible moves dot sum, and then we want to check if our move that the enemy has is inside of our concerning tiles array. So here we can say concerning tiles dot sum, and then we are going to name this tile, and then tile same position as M. All right, this might be a little bit confusing at first. However, we are going to break this down into a little bit more easy statement. However, if there is an enemy that has the same position as one of the concerning tiles, we want to say valid is equal to false. And then down here, we could say if valid is equal to false, continue, or if not valid, continue. That's the short version. All right, so what are we doing right here? Right here, we have the enemy pieces, and then we loop through all the enemy pieces. And then right here, well, we are going to write this out as well for const move of enemy dot possible moves. And first we want to check if enemy dot possible moves is valid or is not undefined. So if the enemy possible moves is undefined, or we could write it like this, then we want to continue. And then here we loop through all the enemy moves, and then we want to say if concerning tiles dot sum tile dot same position move valid is equal to false. So in short, what we have right here, those 3 lines, are the same as those 5 lines, because right here what we do is, well, let's start from the top and let's comment this out for now. What we have right here is we have all the enemy pieces. We have a boolean that says if it is valid or not. Here we loop through all the enemy pieces and we check if they have moves. If they don't, we skip them. So we only are left with enemies that do have possible moves, and then we loop through all their possible moves. So right here, we are checking each move inside the possible moves array, and we want to check if that moves, or if that move corresponds with one move from the concerning tiles. So that is this rule. If concerning tiles.sum it has the same position as the move of the enemy, it's not valid anymore. And if it is not valid, we want to continue. All right, so we have two for loops right here. This for loop right here is the same as this piece of code down here. So here we say, okay, give me each move from the enemy, check if it is in the concerning tiles, and then set valid to false. What we do right here is we say, okay, for the possible moves from the current enemy, let's type that out. So right here say, we have two sums. So the first one is for check if any of the possible moves in the enemy has is present in the concerning tiles array. So right here we check for each enemy if their possible moves contains a move that is in the concerning tiles array. If one of the moves from the enemy is in the concerning tiles array, we set valid to false. So that's the same as right here. For each move in the enemy possible moves, we check if it is in the concerning tiles array. If it is, then we set valid to false. For each enemy move, which is this part, which is in the concerning tiles array, we set valid to false. This might be a little bit difficult to read. I'm going to keep the top one in it. However, I'm going to add one more variant in order to write this. So if you'd like this style, which I've highlighted more, just watch, because we are going to extend it even more. We don't need two for loops. So if we remove this, and I'm going to paste this, no, I'm not going to paste this right here. If we look at this for loop right here, we say, okay, for all the enemies in the enemy pieces, we check their moves, and we check if their moves are in the concerning tiles array. We could also do it like this. So we could say if enemy pieces dot sum, so if any of the enemy pieces, and then we target the piece, if any of their moves, of their possible moves, sum, and then we target their moves, and then we want to check if their moves has occurs in the concerning tiles, so concerning tiles dot sum, and then we have the concerning tiles, same position as the move. So if there is any enemy piece that has a possible move that occurs in the concerning tiles array, then we want to continue, because we know that it is not valid. So this one liner right here, which you could also split up in multiple lines by moving this sum to the next line and this one to the next one as well. However, it doesn't really like that, but you get the idea. You could split it up into multiple lines. This one liner right here is the same as that we do right here. Well, this might be a little bit more readable, but I wanted to show you this just in case you might want to use this instead of the upper one. It's up to you which one that you want to use. I'm going to remove this because we are going to go with the upper one. However, what we could do is we say if valid is equal to false. So if valid, then we want to break out of this loop. And then we want to do the same right here. If valid, break. That's one easy fix. So if we are looping through the moves and we see, hey, valid is false, then we want to break out of looping through the moves. The same goes for the enemy pieces. If we see that valid is false, we don't need to check anymore. And then right here, we do the actual work, continuing. Great. So let's add a comment to here as well. Checking if any of the... All right. So now that we have that, let's add that one to here as well. what we want to do right then is we want to add the move to the possible moves for the king, because now we know that the rook can move to the king, the enemy cannot attack any space in between, and the king and the rook haven't moved yet. So we now want to add it as a possible move. Nice. All right, adding it as a possible move. How are we going to do that? What we want to do is we want to add the move to the king from the position of the rook, I think. Let's do it like that. So if you take the king and you move it on top of the rook, that should be the move. So we want to say possible moves dot push, and then we want to push the rook dot position dot clone, like so. And if we save this up, it should work. Famous last words, but let's try it out. And as you can see, now that we take the king, we can move on top of the rook. How cool is that? As you can see, it immediately works. We didn't write any bugs, which is great. However, we can still not move with the king, as in we cannot move to the up or left side anymore. That's the thing that I was talking about earlier. Inside of our board right here, we assign the possible moves to this. We want to concatenate it, and we can do that by saying that it is equal to an array of the get castling moves and the king dot possible moves that we already had, like so. So why does this not an array type? Okay, so because the king dot possible moves could be undefined, we cannot append it to this array. Well, we know for sure that the king has possible moves. Well, no, that's also a possibility. If king dot possible moves is equal to undefined, let's continue. And then right here, we can remove the bang. And we can save this up. I'm going to recreate this real quick. Right, and if we now take the king, we can move to the left. We can move on top of the rook. And we can not move to the top because there is a pawn. If we take that pawn, we should be able to move to the top. Great. So, well, as you see, the king moves on top of the rook, but the rook disappears. And that is because we haven't implemented the logic for castling inside of the play move function yet. It is a valid move for the king, but it is not a valid move for the for playing it. Because right now, if we look at our referee right here, we play the move, and right here we check, okay, if it is an opposite move, which is it not. If it is a valid move, then we want to remove the piece that is in that location, and we want to push the piece that we are moving to that location. However, this is all different if we have a castling move. If the move is a castling move, do this. So right here we're going to create a function which will be executed when we have a castling move. How do we know if we have a castling move? Well, you just saw we can move with the king on top of the rook. And we don't need to add that logic to here anymore because we already do it when calculating the possible moves, which is really great. Implementing the logic for castling is what we're going to do in the next episode. You could also try that out yourself right now if you want to. For now, I want to thank you for watching. I hope you could follow along. Leave a like, comment down below, subscribe, and I'll see you in the next episode. Bye!